Previous segment we learned how to add two waves together in general. So now we want to look at a particular way of adding two waves when the two waves are identical to each other. And so this is going to produce interference. So interference is going to be when any two waves are coming together, but this is a particular kind of interference called constructive and destructive interference. So we want to go back to our simulation here and notice that the two waves have different frequencies. They also have different amplitudes and they have different phases. So what we want to do is to have two waves that are identical to each other. So they're going to have the same frequency and they're going to have the same amplitude. All right, so go to this simulation and do that for me. So adjust the sliders so that the two waves have the same amplitude and they have the same frequency. Okay, so the top one was the amplitude. So I am going to adjust this so that these two waves, the green one and the blue one, have the same amplitude. Now they need to have the same frequency. Now this is kind of hard for me to do because I can't read these things, these numbers, because they're like 6 feet away from me while I'm taping here. But what I can do is I can take this wave and I can move it so that it is right there. Ooh, that was pretty good. So I move it right there, and now I can change its frequency, so that the two of them have the same amplitude and they both have the same frequency. Now I can move it off of it like this. Now there are two kinds of interference, constructive and destructive. So let's first do the constructive interference. Constructive interference is going to occur when one wave is at its maximum at the same time the other wave is at its maximum. So that we can have wave A is going to look something, let's say, like this, and then wave B is going to be identical to it. It's going to have the same amplitude and the same frequency, same wavelength, but whenever this one's at its maximum, then this one needs to be at its maximum. Whenever this one's at its minimum, this one needs to be at its minimum, and then maximum and maximum again, so that I need to really just reproduce a copy of that original graph. And so I end up with something like that. So whenever this one's at its maximum, this one's at its maximum, minimum, minimum, maximum, maximum. We're going to add them together. Okay? So that means that what do I need to do in order to have that occur? I'm going to need to slide this one. Whoops, I was just changing the frequency there. So I need to slide it so that it's basically on top of it. Now you can do a better job than I can of this. But notice this one's at a maximum. The blue was at a maximum when the green's at a maximum. Now if we wanted to do it mathematically, we would draw another line, and then that would be C. We would measure this distance, we would measure this distance, add them together, and then let's say this one's a 2 and a 2, so 2 plus 2 makes 4. So I would need to go up 4 units to right there. This one would be a -2, -2, so I would need to go down -4 units down to here, and then this one would be a up here like that. Okay, now let's connect the dots. Now this line is where it's crossing, and then this is where it's crossing, so that must mean that this is where it's crossing. If we draw a line straight down through everything. We get that. And we can do the same thing here. It's crossing here, so that must mean that it's crossing here. Draw a straight line down. And now if we were to connect it, we would get something like this. Okay, and notice you get an extra tall wave. So when you add a peak to a peak, you get an extra large peak. And so let's just verify that. Click on the red one, and then you get that. So that's going to be called constructive interference. In constructive interference, two identical waves are going to go together so that they make an extra tall wave. But there's another thing that we could do. We could do destructive interference. So let's get rid of the red one and go back to our two identical waves. But this time, let's put it up here. What I want to do, we'll keep A the same, but B needs to be the opposite of A. So whenever this one is at its maximum, this one needs to be at its minimum. And when this one is at its minimum, then the other one needs to be at a maximum. Okay, and it's still going to have the same place that it's cutting through in each case here. So this is kind of hard to draw, but it needs to look something like that. So it's the inverse of this one. It's like we took this one and we flip it upside down and we get this one here. So what do you think you would get when you add them together? Just take a guess. Well, it's going to be destructive interference, so something not nice is going to happen when you add the two waves. So how could I simulate that on this? So this one was, it's going up when the other one's going up, but what could I do so that one of them's going down when the other one's going up? Well, what we're going to do is go over here and we move the one that slides it back and forth. And was that this one? Yeah. So I'm going to move it so it's like that. So when the green one's going up, the blue one's going down, and vice versa. So what do you think is going to happen when you add the two waves together? All right, well, this one didn't work out the way I wanted it to, so let me tweak it. That's better. So if you had exactly the same frequency and you had exactly the same wavelength and exactly the same amplitude, and then you adjust it so that they are out of phase with each other, 180 degrees out of phase, then you should get a perfect red line there. And so the amplitude of the resultant wave, so C is what happens when you add A plus B, so C should be just a straight line, and it shouldn't have any amplitude to it. And so that's going to be called destructive interference. Now notice sometimes you could have partial destructive interference, which is actually what we've got right here, and that's mainly because of I didn't get the frequencies quite right. But notice what would happen if I increase the amplitude of that one. Okay, so that my green one here has a larger amplitude than what the blue one does. So you notice that for the most part, the overall amplitude is small, but it still has a little bit of amplitude because the green one was bigger than the blue one. So you can have partial destructive interference. You could also have partial constructive interference as well. But we're interested really in total destructive and total constructive interference. All right, so now we can go back to the notes. And constructive and destructive interference can occur both with transverse waves and with longitudinal waves. So let's review what do we mean by transverse and longitudinal. Take the slinky and stretch it out, and then take the slinky and snap it up and down like this. And then what that's going to do is it's going to send a pulse down the slinky that's going to look like that. That is transverse. So what we've been doing has been transverse waves. And all light waves are going to be transverse waves. So when we start talking about light, we're always going to be referring to wiggly lines like this, transverse waves. But you could also take the slinky and give it a shove. And so when you give the slinky a shove, what you're going to find is some parts of the slinky are going to be more compressed together, and then other parts of the slinky are going to be more stretched out, and then it's going to be more compressed again, and then it's going to be more stretched out. So that we can represent a constructive interference would mean if it's transverse, it's going to be extra tall or extra deep. So it's always going to be a larger wave when you do that. If it's a longitudinal wave, it's going to be even more compressed, or it's going to be more stretched out when you do that. So sound waves are going to be longitudinal. Light waves are going to be transverse. Okay, then you've got the destructive interference. So we're going to add together two transverse waves, and you see what it ends up being. And we're going to add two longitudinal waves together, and we see what happens. If it is light, what does destructive interference look like? All right, now remember that the amplitude is related to the energy of the wave. So in the case of light, you would not see it. If it interferes destructively, your eyes are going to see the color black, the absence of light. What is it going to sound like if it's a sound wave and it's being destructively interfered with? You're not going to hear anything. All right, what's constructive going to look like? So you're going to see constructive light, and it's going to be extra bright. And if it is constructive longitudinal and it's sound, it's going to be extra loud when that happens. So for purposes of the exam, I would want you to be able to do it this way with the transverse waves. So be able to explain why is it extra large and extra small, depending on whether it's constructive or destructive. Be able to add the waves together mathematically with a ruler. Be able to draw the two waves on top of each other if it's constructive, or out of phase like this if it is going to be destructive. So I would expect you to be able to do all of that. So an example of constructive and destructive interference is going to be noise canceling headphones. And so they make use of destructive interference. So that the whole idea of these is you put the headphones on and you want to listen to music. You don't want to listen to conversations that are out here. So that's noise. So that's going to be noise that needs to be canceled. So let's just represent the noise that's coming into this ear as a simple wave. Now it's got to be more complex than that, but let's just represent it like this. So what the noise canceling headphones does is it takes that noise And for this ear over here, it flips it upside down. So it takes the noise and electronically flips it so that it is coming into the electronics on this side like this, so that when you add the two together, then you get destructive interference. And so that eliminates the noise, and then you can listen to the music, and you don't have to listen to all the stuff that's going on out here. So the idea of constructive and destructive interference is very important. Okay, let's take a break, and when we come back, we will talk about AM and FM signals.